My current talk is about the influence of big data management in research and education, but I would focus on the biochemistry and biotechnology as a case study. Curriculum has developed all the time. Every time we have to review again, to see again with the growth of science and technology, like what we are talking right now, how to make learning innovation with the current living. So, why people said like this? You have to learn about science and technology. For educational people, they think like we have to be literate towards science. Now Indonesia is I don't know, Buhera, number 2 from below, or no, number 3 from below, from the level of the scientific literate in the world. I think number 2 from the below, I think. And it's very sad learning about that. Very, very sad, yeah. And that is very important. Like now, people in Indonesia concentrating how to use the technology, not how to develop the technology itself. That's the big problem. We're teaching our students to use the technology. I will talk later about that. This is important about how scientifically literate towards science, because we live in the modern world, and it provides a context of addressing the societal problem. That's important. And then when we literate towards science, like now, I'm not literate to use this. So I have a difficulty to use this because I just don't know. And then why? Because if we literate towards science, we better cope in many problems. We also make intelligent and informed decisions. We also have improved in quality of life. That's important. And then that's a problem. Now we are talking a little bit about science. Now we were talking before about the science education. Now we're talking about what is science itself. We know that science is the process or is the product of a scientific activity. What we know is the scientific activity is occurring at every corner of the world. What we are doing now, we are doing science also in education. The problem is we are doing right now here, and maybe other people are doing it in another part of the world. We don't communicate with them. And then makes a very bad impact on the growth of science and technology. Like now, in Indonesia, maybe we are doing biotechnology, and other country doing the plant biotechnology, maybe other country doing the crystallography, and other country doing the sequencing of DNA in the field of biotechnology. But this one, if they don't relate each other, they don't mean anything. They don't have any contribution in life. And then what happened? From their activity, they produce massive data, a lot of data. Our students every day making data, either the good data or the bad data, they every day producing the data. But if you put the data just on your laptop, no use. No meaning at all. Then what we are doing right now, we are coming here, we are connected with people in the community of learning innovation, then we make something a little bit better. What we do now is, before that, I'm going to show you the growth of science. If we see what the publication or the, on PubMed, publication of medication, here, if we see here, from 2003, it's steady, very little. And then from 2006 to 2007, it starts growing. But then with the growth of information technology, maybe at this moment they already have publication, but they don't share with each other. But this, which is recorded by the PubMed, it's growing very fast, and even probably this one is going to be exponential. And that's very important. Like Ms. Saida before, this is important. Data is important. Why? Because the data is the base of the next research or the source of learning. That's very important. And this can grow, depend on two things what I see. The first is the funding. Funding is important. Yeah, funding is important. Without funding, we could do anything. We cannot do anything. And the second is the young generation awareness towards science and technology. When the young generation doesn't aware about science, the science is just finished. So the problem in Indonesia, the awareness towards science is quite low. What they try to get is the job after finish the graduation. What money they would get, what car would they get, house, better life, that. But everybody doing that, I don't blame them. That's okay. Yeah. And then we'll see. What are we doing now? We are building the community of science. We have a community here who is learning about innovation. And people are doing that everywhere. Every seminar, every conference, every scientific activity, they are trying to communicate each other, share their knowledge, share their data. But if you just keep their data here without publishing further, there's also no use. Maybe they will get some use, but very, very narrow. Not that reliable, not that significant with the word progress. Luckily, we have to thank who invent the information technology, because the invention of information technology would make transfer of data is possible. We now can access the internet, we can search with just one word, and then we can get 1 million of data from that. And that is very valuable. That is very important. And then if we see further, now from this we can see the connection between community of science. Here we can communicate with the people. Of course we cannot face-to-face communication, but we communicate by their writing. That's what we see. And then if we see further, you can see, I just picked up this from the internet, we can see here how big the interaction on science between one and other community in this world. And they have the community their own. For myself, I have community on biochemistry and biotechnology because I'm biochemist. I don't have the degree of doctoral and education. That's why I'm not allowed to do research in education. Because when I increase my functional level, they just don't respect with that. But I'm the one who likes to teach. That's why I'm trying to absorb this, to use this data for my teaching. So because of that, now the community of science becoming global. When you write in the certain publication, then they will refer to your publication. They will use your publication as a reference. That's the result of the global community of science. Now I'm getting back a little bit. That was the idea, the global idea, but I would like to give you the example on my field in biochemistry and biotechnology. Here, the biggest community of science in the world right now, this is the National Center for Biotechnology Information, NCBI, which is funded by United States government and open access to everybody in the world. And I think people who learn or study in biochemistry and biology, they know about this. But I would say to other people who is not learning in biochemistry. This is one example of the big data management ever exists in this world. Where does it come from? In about 1989, when I was still probably the last year of my undergraduate study, people already thinking about making, collecting the data about human DNA sequence. They call it the project as Human Genetic Project. They sequence for every single gene available in human. But then they're thinking, one people doing it in Europe, one people doing it in Japan, one people doing it in United States, in England, how to collect the data. And then at this moment, I forgot, maybe the Oxford University, I don't know, forgot, who volunteered to collect the data and store it in one big computer. But the data is becoming overwhelming, and they don't have a funding. Finally, for the next here, the creation of human database is funded by the, several government, and then they make the human genome project database. This funding is not growing. It's difficult to get fund at this moment. They don't believe with human genome project at this moment. And then for the next, here, a Canadian public and private source offer the funding to manage the data. After that, become growing, and then next, it's handled by Research Triangle Institute in United States, and becoming the host of human genome project database. And unfortunately, on 2008, the ICLI was shut down because no funding. That's why I say funding is important. After that, then United States government starts seeing the prospect of the research, and then some of the data is transferred to the National Center for Biotechnology Information, and they make the database, and it's accessed until now with all information, software, and everything is stored over there. Here, this is the, if you want to see the database, this is the database. You can dial www.ncbi.nlm.nih.gov. This is a database for the biochemistry, biotechnology. All database are stored here, and you can just click on everything. We can harvest from the database, and we can use it for many things. What I did as a researcher in biochemistry and biotechnology, I used that information. For example, we just did the modeling on certain protein. We compare to all the protein available in the database, and then we can make a new idea what we can do with it. Maybe we can do with mutant, we can make some other thing. So the research is continuing, and that's happened in all corners of the world. The problem is there anything like that in education? Not yet. Some of them, yes. For example, I forgot, SciTube or whatever, I forgot. This is posting all the funding in education, in science education. Some of them, I found like 6 of them, of the community of science will have already website, some kind like that. But now, most of us here are expertise in science education. That's what we have to learn from biotechnology and biochemistry. How to store all database in the one big storage, and it's accessible for any people in the world. So,
excuse me, Ibu, just 10 minutes more.
Okay, thank you. Will be fast. Now, what research is doing, scientific research doing, they all basically this, we know already, but making observation, thinking about research question, and then for the real researcher, scientists, they're just coming back to this, I think really finding the real method, the good method, and then make people believe what they did, and then they just make the theory. After they believe, and they make sure that whatever they did is right. When they are not right, then they cannot publish it. But the difference between science and education, the educator is mimicking the scientists what they did. Basically, they are not doing this. But what they did is they are doing this one. This one is what the scientists did. That's what basically how we did scientific teaching. Now I'm trying to share with you how I use this data to change the environment in my teaching in my class for biochemistry, and some of students here followed my class last year. Now they are on the 8th semester. They follow this model of teaching. This is the, sorry. This is the common model of problem-based learning. And we can use the database at any corner of this cycle. For example, I took this cycle. We can also use it to problem here. We keep the data, ask a student to analyze the data, posting the problem, we can push it in. But I push it here. I asked students to use the database and analyze it to get the information they get, to make theory, but I did not ask them to read the book. I said to them, none of them in the books. Don't open the book. Because when they open the book, they're already taking the theory, and that's useful, not useful again. The PBL become drop, it's not PBL, becoming a traditional lecture. So this is what I did. Here, I problemed the forcing, posing the problem. I asked, maybe every audience here can answer my question. What is protein? Anybody can ask, what is protein? Bu Hera? Maybe some other student, other audience here, what is protein? Anybody can answer? Nutrition, tempeh, tofu. That's what my student at the 6th semester studying chemistry, answering about the chemistry. I'm so upset about the question, the answer. They just finished studying the organic tree, which is teaching about the chemistry, structure, and everything, but they don't answer the definition of protein at all. In 3 classes, no one answering the definition of the protein. We can see the traditional teaching is very bad, entering the brain of the student. They're just passing like this. Teacher coming, kemudian giving this teaching, protein is blah, 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 they just like this, and they just go home, they just, tomorrow will get exam, and tonight they will read, and then whatever. Forget it. After I finish this, I'm not going to do that. It's okay, fine. But then I try to change the technique of teaching. I give this electron transfer. I said there is a protein here. No name the protein, no structure the protein. I said, I only asked them, see, do they have this different function? Yes. So find out what is the protein. I give the name of the protein, and I asked them to dig the database, to open the database. I equip them with the software, teach them the software, how to operate the data, like what Ms. Saida and Mr. Yutaka said. And then I asked them to learn by themselves. I said to them, bring the laptop, at least one for every group. What they did, they are busy because they like learning, they like searching. The C generation like to do their work on any new gadget. So I just observed they were like to searching, to see. I give you, okay, this group working on this group working on this group working on this, and then this share. I give the instruction every step of what they have to do. And then after this, as you see, they start they seriously working, and then after that, I ask them to present the knowledge, knowledge what they get, the new knowledge they get, and then to try to solve the problem. And incredible, they could do it, they can do it. And I'm not like, wow, this is unbelievable. I should do it every, because this one actually for the Nobel project last year, because we are forced to make a proposal for the ISDB to make the learning innovation proposal, and I did this, and it worked, it's very good. And then what I learned from that, from this changing the situation, they have higher test score, they have deeper understanding, they have broader knowledge, high motivation, but I have longer time in teaching, but it's okay, it's pay off. Because after that, when I'm teaching for the next content, it's easier. they can answer very easy without reminding them again, okay, this one here, forget this one here. No, they just, because they absorb deeply in their brain, they found out the theory, the context by themselves, they use it for the next teaching, for the next learning. So that's what I did for using the database for teaching, but we can also use for the many model of teaching as we want. That's what I can share with you all of you, and thank you.